In this video, we're going to continue topic 3.1, the chain rule. We're still working with a graphical stem. We're going to look for our inside function, which is g of x. So u equals g of x, which means that u prime equals g prime of x. I am going to rewrite my r of x function, which would be the natural log of u. And we're going to take our derivative. So we know the derivative of the natural log of u would be 1 over u. And then I multiply that by the derivative of the inside function, which is g prime of x. I am going to rewrite my r of x derivative with my u substituted in, which is 1 over g of x, and then times g prime of x. We are now going to substitute in the -1. So r prime of -1 equals 1 over g of -1 times g prime of -1. So we're going to look at our graph. We've got 1 over g of -1. So I'm going to go to -1 on my graph. And I am going to read off the y value of 2. So I get 1 over 2. G prime of -1 means I need the slope at -1. So my slope triangle here at -1 looks like it is down 1 over 2. So I'm going to write -1/2. So I have -1/2 times -1/2 would be -1/4. All right, our final graphical stem problem here is we have the u is going to be e of x. So u equals e to the x, which means that u prime is also e to the x. And I'm going to rewrite my d of x function as g of u. We're going to take its derivative. And so we know that it's g prime of u for the outside times the derivative of the inside, which is e to the x. And now we're going to substitute in a 1. So d prime of 1 equals g prime of, oh, I missed substituting my u in. I got to put my u in. My u is e to the x. I shouldn't have done the 1 yet either. So this has got to go back to an x. E to the x. Now I'm going to put in my 1. G prime of e to the first times e to the first. So we have g prime. So we're looking for the slope at e is basically what's going on here. So I'm going to go to my g graph, okay? And we know that e is actually equal to 2.718. So as long as I'm between 2 and 3 and there's the same slope between 2 and 3, that's the slope I'm going to read. So it's kind of a unique problem here. So let's look at this graph here. So if I'm between 2 and 3, 2.718 is somewhere in here. So I'm going to just use this slope triangle right here. So it's totally doable to get this off the graph. We're going to go down 2 and over 1. So it looks like I am at -2 and then e.